Hi there, Mr. Muhammed is here. This is Oxford Complete Mathematics for IGCSE students, Unit 7.3. So this time we are going to find the equation of a straight line. The equation of line. To find the equation of any line, we need to know two things. The first thing is the gradient, and the second thing is the y-intercept. The y-intercept is very important to find the equation of a straight line. So we need the gradient and the y-intercept. Question 1. What's given? A line passes through 0, 7 at a gradient of 3. Then it means the gradient of the line is 3. Question 1. We need to write the equation in the form of y equals mx plus c. M is the gradient, and it's given in the question that the gradient is 3. So it means the equation of question 1 looks like this: y equals 3x. How can we find c? What we know, the line passes through 0, 7. Okay, 0, 7. In this 0, 7, the first number stands for x, the second number stands for y. If we put 0 in place of x and 7 in place of y, we can get the value of c. Now let's just put the 0 in place of this x and this 7 in place of this y, because the line of this equation passes through this point as it's given in the question. Now let's substitute. Then instead of y, we're going to write 7 equals 3 times 0 plus c. Then simplify this. 7 equals 3 times 0 is 0 plus c. c plus 0 is equal to 7, so it means c is equal to 7. Now we are able to write the equation here. The equation is like this: y equals 3x, y equals 3x plus 7. Because we got the value of c is positive 7, that's why we wrote plus 7 here. Question 2, a line passes through this point and the gradient is 2. We're going to use the same procedure to find the equation of the line that satisfies these two conditions. Here, the gradient is 2, so for question 2, the gradient is 2, it means y is equal to 2x plus c. To find c, we will use the point. In the point, 0 stands for x and negative 9 for y. Let's put 0 in place of x and negative 9 in place of y. We will get negative 9 equals 2 times 0 plus c. We say plus c as we do in the standard form, but sometimes c is a negative number, so it's okay if we get a negative number for c. Then 2 times 0 is 0 plus c is equal to negative 9. 0 plus c is just c, so you see negative 9 is equal to c. So the equation is like this: y equals 2x minus 9. This is the equation of the line that passes through 0, negative 9 with gradient 2. Question 3, the equation of question 2, y equals 2x minus 9. Now question 3, a line passes through 0, 5 at a gradient of negative 1. Then for question 3, since the gradient is negative 1, so y is equal to negative 1x, or just negative x. To find the c, plus c. It's not necessary to write plus c. It's not necessary. We can do it like this. We are sure that y is equal to negative x plus or minus something. To get what's remaining in the equation, we substitute the given points, coordinates, x and y in the equation and see. X is equal to 0 and y is equal to 5. So 5 is equal to negative 0 plus c. To get the value of c, to get the value of what's missing in this linear equation, which is plus c, the constant, the number alone. Then c plus 0 is 0, it has no sign. Negative 0 is still 0. Plus c is equal to 5. 0 plus c is just c, which is equal to 5. Then we got that that c is equal to 5. Then we can complete the equation. Negative x plus 5. This positive 5 is the value of the constant, the value of c, and the gradient is negative 1. It's given in the question, so we got everything right. Now question 4. Passes through 2, 3 with gradient 2. So y equals 2x. Why? Because the gradient is 2. Y equals 2x. Because the gradient is 2. It's given in the question. Y is equal to 2x. Plus c. What could this c be? To find the c, we use the given point, which is 2, 3, like this. 2 is the first entry, so it's x. 3 is the second entry, it's y. Then 3 equals 2 times 2, the value of x in the point, plus c. 3 equals 2 times 2 is 4, plus c. What should we do to 4 to become 3 if we subtract it by 1? So it means c is equal to negative 1. So 4 minus 1 is equal to 3. We got the value of c. C is equal to negative 1. Now we can complete the equation. The equation of question 4 is y equals 2x minus 1. A quick way to check your answer to see either it's true or false, just substitute the point in the equation and see, will you get something correct? Let's check. Again, we're going to put 3 in place of y and 2 in place of x. Let's see, will we get something correct? 3 is y equals 2 times 2 minus 1. 3 is equal to 2 times 2, 4 minus 1. So we got both sides equal. It means the answer is correct. When you substitute the point in your equation that you got for the line that passes through this point with a given gradient, if you didn't get both sides equal, it means something went wrong with the y-intercept or with the gradient. Question 5. The line passes through 211 and the gradient is 3. When the gradient is 3, it means y equals 3x plus c. Okay, then how can we get the value of c? By using the point. Then y is 11 in the point. We substitute 11 in place of y equals 3x is 2 in the point plus c. 11 is equal to 3 times 2, 6 plus c. So you see that c is equal to 5 because 5 plus 6 is equal to 11. Or send the 6 to the other side, make the c subject. Then you see something like this. 11 minus 6 is equal to c. So from this, c is equal to 5. Then can we complete the equation now? Yes, because we got the value of c. It's positive 5. Question 5, the equation is like this. y equals 3x plus 5. From question 7, 6 and 7, again, you see one point is given with the gradient, and like how we did the last 4 questions, you can find the equation of the graph, question 6 and 7. So I'm going to do 7 because the gradient is fraction. Let's see how can we deal with this. And the last 4 questions here, from question 8 to question 11, there is no gradient. We have to find the gradient and then the y-intercept. I'll show you how. Question 7, the gradient is 1 over 2, so y is equal to 1 over 2x plus c. C is missing. To find c, we use the given point, which is 6, 0. Then we're going to put 0 in place of y and 6 in place of x. 0 equals 1 over 2 times 6 plus c. 1 over 2 times 6 is half of 6, which is 3, plus c is equal to 0. 0 is the value of y given in the point. Then 3 plus which number will be 0? Of course, with negative 3. It means the value of c is equal to negative 3. If it's not clear in this step for you, you can send this 3 to the other side to have c all along on the side. Then you see negative 3 is equal to c. Now we can complete the equation. Since it's equal to negative 3, then y equals 1 over 2x minus 3. This minus 3 came from this negative 3. Question 7, done. We got the equation. Question 8. Previously, we learned how to find the gradient when we have 2 points. So we're going to do the same thing. We will find the gradient, then substitute the gradient in the equation, and use one of the points to help you find the value of the y-intercept. Okay, to find the gradient, we'll say y2 minus y1 over x2 minus x1. Let's call these 2 points y2 and x2, and these 2 points y1 and x1. Then gradient, g, gradient, or usually gradient or slope is named as m, but it's fine, it's just naming. Why we call it m? Because in the standard form, y equals mx plus c. So m is the gradient. Okay, how can we find gradient from 2 points? We say y2 minus y1. y2 is 5 minus y1 is 1 over x2 minus x1. x2 is 4 minus x1 is 2. Now 5 minus 1 is equal to 4. 4 minus 2 is equal to 2. Can we simplify this? Of course we can. 4 divided 2, 2. We got the gradient. The equation looks like this. For question 8, the equation looks like y equals 2x plus c. Now it's time to find c. Why 2x? Because we got that the gradient is 2. So y equals 2x plus c. To find c, in questions 1 all the way to question 7, we had only one point, and we used the point to find c. In question 8, 9, 10, 11, and any other question that has the same form, we have 2 points now. We can use any of them to find c. Usually use the easier one, just to save time. Now, in this point, y is 1, x is 2. So let's put 1 in place of y and 2 in place of x to find the value of c. 1 equals 2 times 2 plus c. 1 equals 2 times 2 is 4 plus c. Send this 4 to the other side to have c alone on the side. or in other words, to make C the subject, then we will have 1 minus 4 equals C. 1 minus 4 is equal to negative 3. So C is equal to negative 3. We got the value of C. We can complete the equation. So for question 8, y equals 2x minus 3 is the equation. Let's check this answer. We can check this answer by substituting 2 in place of x here and 1 in place of this y. Let's see, will we get both sides equal? Let's check. If we put 1 in place of y, we'll see something like this. 1 equals, and 2 in place of x, 2 times x means 2 times 2. C is negative 3, then minus 3. The side is equal to 1. 2 times 2 is 4, minus 3, 1. Both sides are equal. It means the calculation and the equation are all right. Question 8, done. This is the equation. Now let's start question 9. Question 9, the points are like this. So to find m, or the gradient, y2 minus y1 over x2 minus x1, let's call these two x and y, x2 and y2, and here x1 and y1. y2 minus y1 means 7 minus 4 over x2 minus x1 means 6 minus 5. 7 minus 4 is equal to 3. 6 minus 5 is equal to 1. So the gradient is equal to 3 over 1 means 3 divided by 1 is 3. The equation looks like this. Y equals 3x plus c. C is missing. Let's use any of these 2 points. Let's use this one to find the value of C. How can we use this point? We use this point by writing 7 in place of y and 6 in place of x. That's how we substitute a point in an equation. Then y equals 7 equals 3 times x is 6 plus c. 7 equals 3 times 6 is 18 plus c. 18 minus which number will be equal to 7? You can send the 18 to the other side. You will have 7 minus 18 equals c. 7 minus 18 is equal to negative 11. C is equal to negative 11. From this, c equals negative 11. Now write the value of c in place of this c, which is synonymous in the equation. 3x minus 11, done. This is the equation of question 9. Y equals 3x minus 11. Now question 10. Question 10. The points are 0, 5, 3, 2. Then question 10. M, or the gradient, is 2 minus 5 over 3 minus 0. 2 minus 5, 3 minus 0. 2 minus 5 is equal to negative 3. 3 minus 0 is equal to 3. 3 divided 3 is equal to 1, and this negative will stay. The gradient is negative 1. Then the equation looks like this. Y equals negative x plus c. To find c, we use any of these 2 points. This one looks easier. Let's use 0, 5. We're going to put 0 in place of x and 5 in place of y. Let's see what we get. Then 5 in place of y, 5 equals negative 0 in place of x plus c. Negative 0 is still 0, plus c is just c. So c is equal to 5. To complete the equation, or we can rewrite it from this, y equals negative x plus 5 is the equation of question 10. Question 11 and the last one. Where to start? We start by finding the gradient. How can we find the gradient? By writing y2 minus y1 over x2 minus x1. What is y2 and y1? y2 is from here, y1 is from here. It's fine if you say this point is x2 and y2, this point is x1 and y1. It's all right. Question 11. M, or gradient, is -1 minus -3. This minus is from the rule, and this minus is for the -3. In the denominator, we will have 9 minus 3. Then -1 minus 3 will be like this, -1 plus 3 over 9 minus 3. Now let's do it. -1 plus 3 is equal to 2. 9 minus 3 is equal to 6. We can simplify it by 2. 1 over 3. The gradient is 1 over 3. Then the equation looks like this because we got the gradient. We got the number which is before x. 1 over 3x plus c. To find c, we use any of these 2 points. Let's use this one to find c. We are going to put -3 in place of y and 3 in place of x. It looks like this. -3 equals 1 over 3 times 3 plus c. -3 here equals 1 over 3 times 3 is equal to 1 plus c. 1 plus which number will be -3? Or 1 minus which number will be -3? Well, if we send this one to the other side, it will be -3 minus 1 is equal to c. From this, c equals -4. Now we can complete the equation. C is -4. The equation is 1 over 3x minus 4. This is the equation of question 11. I hope you find it useful. Comment below whatever question you have. Thank you for watching.